Hello friends, please let me know whether voice is coming or not. Hello. वाह भाई क्या बात है. Whether voice is coming or not, please let me know first. थैंक यू कि आप सभी लोग जो है चैनल पे आए हो. थैंक यू. वेलकम टू अनअकैडमी. थैंक यू ऑल ऑफ यू. ऑडिबल है. वेरी गुड. So, first I want all of you to just show thumb in the live section, okay? So, it makes me very comfortable to start the session, okay? Please make a thumb in the session. So, it makes me very comfortable, okay? गुड इवनिंग टू ऑल ऑफ यू वंस अगेन एंड वेलकम टू अनअकैडमी. मेरा नाम वरुण है और आज का टॉपिक है हमारा इंट्रोडक्शन ऑफ ट्रांसफॉर्मर. सो बेसिकली दिस टॉपिक इज इन इंग्लिश. आई ट्राई टू मेक बोथ द ऑडियंस हैप्पी टुडे. सो आई विल टेक स्लाइड पोर्शन इन इंग्लिश एंड स्लाइड पोर्शन इन हिंदी. इज इट ओके? सो प्लीज शेयर दिस सेशन with as many students as you can, so it helps me a lot to make more energetic in this particular session. Now please see the team. This is a complete package to crack the GATE and ESE. A basic, just a brief, please wait for a little while, then we will start. Okay, the topic, please see. Complete package to crack GATE, ESE, okay. Not only GATE and ESE, you can crack any other public sector exam also if you are going to take the advantage of this live session. Okay, now see, this is the team. Okay, now see, I am Varun Srivastava. I don't think much introduction is needed. So I am expert in GATE and ESE, worked with the all top offline institutions in India, mentored more than 70k students. Even maybe it will be more than that, and having 10 years of teaching our electrical machine control system and digital electronics. Many of my students only know about the my subject that is electrical machine. That is not true. My subjects are more than this. Please observe here, this is a code. This code is representing to you. That is VST101. Okay, so you can just join by this code and you may get connected directly and you will also get the benefit. Okay, so this is just a joke. You can use this code in order to get the 10% subscription off. Okay. You can follow me as on the app as unacademy@machine.varun. Okay, now I will let you explain two more things on this. Of course, on the special classes I am going to take the things in Hindi. तो मैं आपको यहाँ पर जो है हर एक बात को बताता चलता हूँ. 2 मिनट मेरे साथ बने रहिएगा. See, we have a 2 plans, that is Iconic and Plus. I always say to get involved in such a manner so that you can utilize most of the things. Okay, so see here. We have a 2 plans here, that is Plus and Iconic. If you observe Plus, then the boundaries are there. So within the certain boundary, the things will be there. Okay. So it is very good that Plus is going to help you a lot. That is also a free course. Live classes, crash course, weekly test, doubt solving, Hindi, English. तो ये Plus के लिए घेरा बना रखा है, आप समझ रहे होंगे. और Iconic जो है वो इन घेरे के बाहर है. So you can observe that Iconic will have a more influence. Okay, so later on we will discuss what is the price and so on. I am hoping that is sufficient. Okay, now please see, you can join the subject for 18 month, 12 month or for 24 month, you can log in on Unacademy Plus app by using my code, that is VEST101. Okay. Now before going to start the session, I just want to know कि आप लोग मेरी बात को थोड़ा बहुत समझ पा रहे हो कि नहीं. आई एम वेरी हैप्पी टू सी कि बहुत सारे लोगों ने जो है अपना बहुत सारा प्यार दिखाया है. थैंक यू, थैंक्स अ लॉट. तो आई एम होपिंग कि जो है प्लस कल से स्टार्ट करने का है प्लान. मे बी आई स्टार्ट प्लस बाय टुमारो. ओके, सो यू कैन ज्वाइन द ऐप बाय यूजिंग माई कोड एंड यू विल गेट मशीन फ्रॉम द रिविजन पार्ट. ओके, सो इट विल बी गोइंग टू हेल्प यू अ लॉट. मैं थोड़ा सा कमेंट सेक्शन को लेना चाहता हूं, तो आपका कमेंट सेक्शन में देख रहा हूं, एंड देन आई विल जस्ट गोइंग टू स्टार्ट अ ट्रांसफॉर्मर टॉपिक. ओके, इफ एवरीथिंग इज ओके, जस्ट मेक अ थंब एंड वी प्रोसीड फर्दर. जस्ट मेक अ थंब. इफ यू वांट टू आस्क एनीथिंग, you can ask in the comment section, or I'm also interested to start this. Sir, what did 2020 batch? First you come on the app, okay, and most of the things even I don't know, so I have to check the things ki how we are going to plan. Okay, so I'm quite new on this. नहीं आ रहा है, अच्छा ठीक है. बस इतना सिंपल सा था कि आपको जो है एक अनअकैडमी का ऐप डाउनलोड करना है, ठीक है, और उसके थ्रू आप जो है ऐप पे भी मुझसे पढ़ सकते हो. ऐप का फीचर काफी डिफरेंट है फ्रॉम द यूट्यूब. यूट्यूब इज ऑल्सो वेरी गुड. ओके, नाउ सी, सो शैल आई स्टार्ट नाउ? गुड टू सी यू सर. थैंक यू अ लॉट, थैंक यू अ लॉट. लव यू ऑल बेटा. थैंक यू अ लॉट, थैंक यू अ लॉट. नाउ सी, let us first talk about the transformer. Why we need transformer? Okay, so the basic necessity is electricity. Okay, so most of the things in that way ki how the electricity will generate, and then it is going to transmit, and then we are going to consume. Okay, so if you observe the for the process, you can please see here. I practice a lot, maybe I'm not so good. Please explain in English. I'm taking in both the languages, and the entire crash course is going to be in English only. So today only I am going to talk in both the languages. It is going to help all other students also to understand. Okay, now see, let us suppose we have to generate whenever I am saying ki let us see, you have to observe to me. Okay, and when I write something, then you have to go on to the board. Okay, so this makes interaction level better. Okay, so see, see, if you observe here, see, if you observe here, let us suppose we have a generating station. Okay, so from the generating station, let us suppose we have a hydropower plant. तो मान लीजिए हमारे पास ना एक हाइड्रो पावर प्लांट है, और वो हाइड्रो पावर प्लांट है, मान लेते हैं एक यूनिट है 500 MVA की. लेट अस सपोज वी हैव अ 500 MVA हाइड्रो पावर प्लांट. ओके, एंड दैट इज गोइंग टू गिव द सप्लाई to say domestic and industrial users which are far away from the generating end. Okay, so if you observe here, let us suppose a three-phase supply. Generally we have a three-phase 4-wire system. So let us suppose we have a three-phase supply, and the generator is going to generate at say 11 kV. Okay, so soon I am going to very comfortable to this board also. Okay, so don't worry about that. See, we have a 11 kV and 500 MVA generator, and if you have to transmit over a very long distance, then you have to keep two things in mind. Always whenever we transferring electrical energy by a direct electrical connection, then that is through the wire. Okay, and the wire thickness depends upon the current handling capacity. Okay, so अगर मान लीजिए हमारा ये 11 kV का जनरेटर है, 500 MVA का जनरेटर है, इसके पर फेज की बात करता हूं, तो जो करंट होगी ना वो कितनी हो जाएगी? सो यू कैन ऑब्जर्व द करंट हियर, दैट इज 500 into 10 to the power 6 divided by √3 into 11 into 10 to the power 3. Okay, So you can say, sir, this is in kilo amperes almost. Okay, so this kilo ampere current, in order to handle a kilo ampere current for a very long distance, we have to think for that, because the thickness of wire is very high. Always remember, the wire comes in terms of the thickness or in terms of the current rating. Okay, so for a high current rating, the thickness of wire needed to be very high. It is quite difficult to hang over the towers, so we must have to reduce the current rating, and in order to do that, we are going to use a transformer. I am representing a single line diagram here, please observe. Okay, so here this is a transformer. If you observe a transformer here, अरे भाई ध्यान से देखो ना, अगर तुम यहां पर ट्रांसफार्मर की बात करते हो, अभी बहुत अच्छा लगेगा तुम्हें, 2 मिनट रुक जाओ, मैं अभी सेट हो गया हूं, ठीक है। सो अगर हम ट्रांसफार्मर की बात करते हैं ना, तो ट्रांसफार्मर में क्या है, आपने कहा सर मान लीजिए वी आर गोइंग टू इंक्रीज द वोल्टेज लेवल फ्रॉम 11 kV to 220 kV. Okay, so if we are going to increase the level from 11 to 220 kV, then current is going to reduce. Okay, and the thickness of wire is accordingly going to be lower and material cost is going to be saved. जब हम क्या करते हैं ना, जब हम 11 kV से 220 kVA पे जा रहे हैं, kV पे जा रहे हैं, तो इससे वोल्टेज लेवल बढ़ रहा है। अगर आप यहां पे देखो तो वोल्टेज लेवल बढ़ने का, जब भी मैं बोलूं यहां पे देखो, इसका मतलब बोर्ड पे देखना है। सो इफ यू ऑब्जर्व, व्हेन वोल्टेज लेवल increases, then what happened, current level decreases. Okay, for the same kVA capacity. Okay, तो आपने बोला सर यहां पर हमारा जो वायर होगा वो हमारा थिन होगा, थोड़ा कम हो जाएगा थिकनेस, क्योंकि हमने वोल्टेज लेवल बढ़ा दिया, बिकॉज वी आर गोइंग टू इंक्रीज द वोल्टेज लेवल, सो डेफिनेटली द कॉस्ट ऑफ द वायर विच इज कॉस्टली एंड इट इज गोइंग टू बी पॉसिबल टू प्रोवाइड ओवरहैंगिंग. ओके, सो द कॉस्ट ऑफ द वायर इज गोइंग टू बी सेफ. नाउ प्लीज ऑब्जर्व हियर अगेन, we can't deliver 220 kV to domestic as well as industrial users. The reason behind that is the insulation level, the insulation level depends upon the voltage rating. So we can't use a 440, we can't use a 220 kV fan, because if we are going to use such a big fan, then it will be more bigger than our house. आप बोलोगे ना सर, अगर हम ऐसा फैन यूज करने जा रहे हैं जो 440 kV का है, या फिर जिसकी वोल्टेज रेटिंग 220 kV की है, तो आपके हाउस से भी बड़ा हो जाएगा. दैट इज क्वाइट नॉट पॉसिबल. इज इट ओके? सो नाउ सी हियर, we use again a transformer to step down. Soon I am going to take all the queries. Okay, अब मैं respond करूंगा. I am going to respond each and every student who is going to be write it on the comment section. So don't worry about that. Presently, please focus on this. Okay, topic. Now see, if we have to again use a step down transformer, and that step down transformer is again going to be stepping down from 220 kV to say 11 or say 6.6 kV. Now, this 6.6 kV can be supplied to the industries as they have larger machines, and for industrial users, and for a domestic users we further use a transformer here, and this transformer is again going to step down from 6.6 to, you can say sir, 440 volts. Okay, so we have a 3-phase system, so this is a 440 volts. 440 volts. Okay, now see, so this is quite possible to transmit and to use the power effectively by having some transformers. So they are very important in our supply system. और जब हम बीटेक करते हैं जब हम अपना जो है सप्लाई सिस्टम की बात करते हैं, सप्लाई सिस्टम की बात कर लेते हैं, या इलेक्ट्रिकल मशीन फ्रॉम द पॉइंट ऑफ व्यू ऑफ गेट और ईएससी, इफ यू थिंक, देन आप कह सकते हो सर कि हमारे लिए ट्रांसफार्मर का यूज करना एक तरह से मैंडेटरी है, बिकॉज द जनरेटिंग स्टेशंस आर फार अवे फ्रॉम द लोड एंड्स. ओके, द जनरेटिंग स्टेशंस आर फार अवे फ्रॉम द लोड end. Is it okay? Now please see, let us talk about some basic things. Okay, Sir, write a little bit bigger. Don't worry about that because ये नया है, so I'm just trying to do in a best possible way. Don't worry about that. Okay, I'm going to write it in a very beautiful manner. See, see, some basic concepts, some basic concepts. Now, some basic concepts. Now, what are the some basic concepts? Please observe. Some basic concepts of magnetic circuits. Some basic concept. Okay. So, in order to understand the entire behavior of the machine, today's class is very important. This is just an introduction so that we will going to be very comfortable to future classes. Okay. Please observe here. मैं अपनी बात को आपके साथ रखता जाऊंगा. Don't worry about that. Visual is not clear. I'm trying to do that. Visual is clear. You have to increase the YouTube quality. Okay. जरा ध्यान से देखिएगा बेटा. जब हम बात करते हैं ना बेसिक कंसेप्ट्स की, तो बेसिक कंसेप्ट में लेट अस फर्स्ट डिस्कस अबाउट द मैग्नेट. ओके, सो you all are aware with the magnet, but I am just trying to show you about something about the magnet. We are aware with the permanent magnet. Yes. Okay, so now please see, we are aware by the permanent magnet. Let us suppose we have a magnet here. Okay, so let this to be the north of the magnet and this to be the south of the magnet. Okay, so if you observe the magnet, whenever we keep the magnet close to any magnetic material or a soft magnetic or a hard magnetic material, we found that they are going to be attracted towards each other or repelled from each other. So that is all because of the magnetic force. So let us try to understand that magnetic force. If we have a magnet, then that magnet is having one force, and that force is because of the spinning of the electrons around their nucleus or around their own orbit. That is what we call it as a small magnet, or you can say a dipole. Okay, so because of the dipoles, magnetic line or forces are appearing in this fashion. Let us take, we have a permanent magnet here. Okay, most of the things I have, sir, please don't bother. We are listening. Thank you, beta. Now, please see. We have a magnet, say north and south. So, what happened? Let us suppose I have one iron piece here. So, अगर मैं इस iron piece को ना इस magnet के पास लाऊंगा तो क्या होगा? आप बोलोगे सर अगर आपके पास ये iron piece है और इस आयरन पीस को आप इस मैग्नेट के पास लाओगे तो दिस इज गोइंग टू अट्रैक्ट दिस आयरन पीस. ओके, सो इट इज गोइंग टू अट्रैक्ट दिस आयरन पीस. एंड व्हाई दिस हैपेंड? बिकॉज these magnetic line of forces are always try to flow through the minimum reluctance path. Now what is reluctance? The different terminologies are going to be come now. Please observe here. These are the magnetic line of forces. Within the material, it always flows from south to north. However, outside of the material, the magnetic force is appearing like it is coming out from the north and going into the south. Now, let us suppose we have an iron piece, and that iron piece I am going to keep close to this magnet. What happened? This is going to attract very sudden. All of the sudden, the magnet is going to attract. Why this magnet is going to attract? Now, please observe. Basically, the permanent magnet will have a dipoles, and these dipoles are permanently aligned in one direction. Okay, so because they are aligned in one direction, so they are creating a strong field. Now please see, iron material also have a magnetic dipoles. Please see, we have iron material here. This iron material also have, let me draw a bigger one. Okay, we have a magnet here, and the magnet is having permanent magnetic dipoles, and the dipoles are aligned in one direction. These magnetic dipoles are formed because of the electron spinning around its own orbit or across the nucleus in some specific way. Okay, that is all because of the material itself, you can say in that way. Now, when we put the magnet, when we put this iron piece close to the magnet, then this iron piece is also having dipoles. Please observe, I am going to show you each and every expression very fast. Okay, so don't worry about that. Every concept is very easy, only you have to follow me. Okay, don't just come and go, that is not a good way. आप बस चैनल पे आए और चैनल से चले गए तो ये सही तरीका नहीं होता. आपको चैनल पे थोड़ी देर बने रहना है, ठीक है, तभी आपको जो मैं समझाना चाहता हूँ वो समझ में आएगा. See, we have iron material, and the iron material also have a dipoles, but these dipoles are randomly oriented. Okay, so because they are randomly oriented, so this is not going to act as a magnet. Okay, but when we are going to put it close to the magnet, then what happened? All the line of forces are going to be forced by this magnetic line of forces. So these magnetic line of forces force these dipoles to align in one direction, and soon as they are aligned in the direction of the field, this is going to act as a magnet with the south and the north here as soon as the dipoles are aligned in this direction. Is it okay? In the right side. Okay, तो आप ये कह सकते हो सर जैसे ही सभी डायपोल्स अलाइन हो जाएंगे तुरंत वो आयरन क्या हो जाएगा, वो एक साउथ और नॉर्थ मैग्नेट बनेगा जो कि आपस में क्या हो जाएगा, चिपक जाएगा. सो यू कैन से कि सर इट इज गोइंग टू अट्रैक्ट एंड देन इट इज गोइंग टू जस्ट you can say a force of attraction it feels, and just it is going to contract if there is nothing in between this. Okay, now please see, now please see, now please see. Now please see, we have some very important relationships. Now please see, now you know about something about the magnet, you have now a basic idea of the magnet. Now please see, now please see, this is just a basic concept and a basic idea of the magnet. So now you have a basic idea of the magnet. Please see, the magnetic field some important relation. Okay, so first important relation is mu. You are aware with the term mu, that mu is equals to mu naught into mu r, where this mu naught is called as a permeability of a free space, and mu r is the relative permeability. Okay, so this relative permeability is basically higher for a soft magnetic material. Most of you are aware with this as you are studying transformer, so I am making the things to be faster so that we will get more information. Okay, now see, we have mu is equals to mu naught into mu r, where mu naught is the permeability of free space, that is equals to 4 pi into 10 to the power of minus 7, and mu r is basically a relative permeability. Relative permeability is higher than 1 for a magnetic materials. Okay, now please see, we have another relationship, that is मैं बहुत जल्दी ना अपने कंटेंट पे आने वाला हूं, so don't worry about that, this is just an introduction, तो आप लोग को थोड़ा बने रहना है. ठीक है, दूसरा है आपका जो सबसे इंपॉर्टेंट है उसको बोलते हैं हम लोग MMF. So now what is this MMF? Okay, this MMF is responsible for the motion of flux, very similar to like EMF is responsible for the motion of current. Okay, so this is what we call a magnetomotive force. This MMF is equals to N into I, or we are aware with the term that is H into L. Okay, this is just a basic, most of you are aware with this. So this n is the number of turn, I is the current flowing through those turn and L is the mean core length. Let us suppose, अभी क्लास को मैं बहुत जबरदस्त करने वाला हूं, ठीक है ना, तो मेरी आदत है कि क्लास को मैं बहुत धीमे धीमे ले जाता हूं. आपको अगर क्लास को एंजॉय करना है सो देन यू हैव टू बी विद मी, ओके, क्योंकि इससे क्या होता है कि इंटरेस्टेड कैंडिडेट बहुत ध्यान से सुन पाता है. ठीक है, मान लो मेरे पास ये एक आयरन का पीस है, ओके. The iron piece will have a dipoles, but these dipoles are randomly oriented. So the force is required in order to make the dipoles to be in one direction. Now please see. Let us suppose we have a coil and the coil is wounded onto the transformer core in this manner. Is it okay? And I am going to give a supply, that is current I, say, okay, by some source, okay. Now let us suppose this number of turns are n. So what actually happened, there are the magnetic dipoles within the material, but these dipoles are randomly oriented. So definitely in order to provide a orientation in one direction, there will be some force is required, and that force is what we call a magnetomotive force. So when we supply a current through n number of turns, then it is going to create a field. And if L is the total length of the material, let us suppose this L is the total mean core length of the material, then you can say, sir, all the dipoles are going to align in one direction, okay, because of that force. So because of the force, the dipoles start aligning in one direction, say in this manner. Now most of the people think, sir, why it is happening, why it is moving in this way only. So for that we have to understand a right hand curl rule. So very soon I am going to discuss about the right hand curl rule, okay. Please see here, beta. Don't write unnecessary things, okay. You are not aware with all that type of information, so you have not a right to comment that things, okay. जरा ध्यान से देखो बेटा, एमएमएफ के बारे में मैंने तुम्हें थोड़ा सा बताया है कि एमएमएफ क्या है. अभी एमएमएफ के बारे में हम लोग थोड़ा और डिटेल में सीखते हैं. पहले मैं थोड़ा इंपॉर्टेंट रिलेशनशिप सारी लिख देता हूं, फिर बेसिक इंट्रोडक्शन दे देता हूं ट्रांसफार्मर का, और फिर हम लोग ना एकदम पूरे टॉपिक को जबरदस्त बनाते हैं. ठीक है, तो दूसरा होता है फ्लक्स डेंसिटी, जिसको हम लोग बी से दिखाते हैं. दैट फ्लक्स डेंसिटी इज बेसिकली नंबर ऑफ, यू कैन से, फ्लक्स पर यूनिट एरिया ऑफ द क्रॉस सेक्शन ऑफ कोर. Say this to be the iron core of having area of cross section A. Okay, so flux density is mu into H, or it is also defined as mu into H can be represented as Ni by L. Okay, and what is flux density? Flux density is flux per unit area of cross section of core. Okay, so you can say, sir, flux phi can be defined as B into A, and B is equals to mu into N I by L up into A. Okay, so this is very important, बहुत ध्यान से सुनिएगा. ठीक है, अभी सर थोड़ी देर में. अच्छा ठीक है बेटा, कोई बात नहीं, टेंशन ना लो. देखो यहां पे जरा, म्यू इज इक्वल्स टू, फ्लक्स इज इक्वल्स टू म्यू इनटू एन आई बाय एल. अरे यार ये थोड़ा सा मुझे ना और प्रैक्टिस करना है इस पे. Similarly, when I started onto the board also, I feel very difficult. So, but I am very adaptable, so I will fastly adopt this technique also. Now, please see, mu into Ni by L into A, and that you can represent in this way, that is N into I by L upon mu into A. This is a very important expression. So, what is this? Now, please observe. What is Ni? Ni is what we called MMF, that is magnetomotive force. Because of the current flowing into the wire, there will be a field created, and that field is creating a force onto the dipoles, and then all the dipoles are going to align in one direction. Okay, and what is this L by mu into A? That is what we called reluctance. So this is very important term, reluctance. Okay, so reluctance is very similar to resistance in an electrical circuit, or you can say, sir, reluctance is L upon mu naught into mu r into A. Okay, like current always try to flow through the low impedance path, or you can say low resistive path. If we have a 2 resistive path, then current always try to flow through the low resistive path. Similarly, flux always try to flow through the low reluctance path. Okay, now please see, we have now a flux, that is MMF upon reluctance. This is the basic part, and most of you are aware with this basic part. Now I am going to start my topic. Okay, transformer. Now see, what is transformer? First of all, we discuss what is transformer, and then we come back and discuss about the right hand curl rule. Okay, now see, what is transformer? Transformer is a static device. Transformer is basically a static device that transfers electrical energy from one electrical circuit to another electrical circuit through magnetic fields without change in frequency. The term without change in frequency is very amazing. Okay, so that we are going to get in a very deep. Okay, now see, transformer is a static device that transfers electrical energy from one electrical circuit to another electrical circuit through magnetic fields without change in frequency. मेरे हिसाब से मेरे स्टूडेंट्स आप लोगों को समझ में आ रहा होगा. सेशन को शेयर कर दो, अब आपकी क्लास चालू हो गई है ट्रांसफार्मर की. ठीक है, तो एक बार सेशन को शेयर कर दो. फर्स्ट वी टॉक अबाउट द यूजेस ऑफ ट्रांसफार्मर. तो यूजेस क्या क्या हैं बेटा? अगर हम बात करते हैं यूजेस ऑफ ट्रांसफार्मर की, तो एक आपको समझ में आता है सर, टू स्टेप अप और स्टेप डाउन द वोल्टेज लेवल्स. ओके, दूसरा आपको समझ में आता है सर, इन इलेक्ट्रॉनिक कंट्रोल सर्किट ट्रांसफार्मर्स आर यूज्ड फॉर इंपीडेंस मैचिंग. इसके बेस्ड ना क्वेश्चन भी आया गेट में, सो दिस इज इंपॉर्टेंट फॉर गेट ऑल्सो एंड फॉर अदर कॉम्पिटिटिव एग्जाम ऑल्सो. क्या इंपीडेंस मैचिंग पे बेस्ड क्वेश्चन, दैट लाइन इज नॉट इंपॉर्टेंट. नाउ सी, in electronic control circuit, transformers are used for impedance matching so that maximum power is going to be transferred from source to load. And also transformer is used for isolating DC while it permits the flow of AC. So it will act as a DC filter also somewhere. Okay, there are many uses, many other uses. So इतने ज्यादा हैं कि क्या डिस्कस किया जाएगा. ये बेसिक आपको जो है मैंने तीन डिस्कस किए हैं. दीज आर इंपॉर्टेंट फॉर यू टू अंडरस्टैंड व्हाई वी आर गोइंग टू यूज द ट्रांसफॉर्मर. मोस्ट ऑफ द पीपल आस्क सर हाउ मेनी टाइप्स ऑफ ट्रांसफॉर्मर्स आर देयर. सो बेसिकली ट्रांसफॉर्मर्स आर ऑफ 3 टाइप्स. फर्स्ट वन इज योर डिस्ट्रीब्यूशन ट्रांसफॉर्मर, एंड सेकेंड वन इज योर power transformer, and third one is your instrument transformer. Okay, so these are the major 3 categories, and within these 3 categories there are many more. Okay, now see, transformer or the machines are going to work on some basic fundamentals that can be understood with a magnetic circuit very easily. Okay, so previously I have shown you about these things. Okay, let us discuss for this also. Now let us discuss for this also. Please see. Let us discuss for this also. Please see. Right hand curl rule. So this is very important and everything is dependent on this. चलो, आवाज आ रही है बेटा? बहुत बढ़िया, ठीक है. अब ध्यान से सुनते जाओ, है ना? सुनना. We all are aware that whenever current flows through a wire, then it will create a magnetic field. Okay? अभी हमने देखा कि अगर हमारा कोई भी वायर से करंट बहेगी तो वो क्या बनाएगी? एक MMF. MMF is just a field. That magnetomotive force is going to create nearby, you can say air, or if there is some material, so that is going to convert it into a magnet. Okay, so here I am showing you the right hand curl rule. We are aware that whenever current flows through a wire, it is going to create a magnetic field, and the direction of magnetic field is found by the right hand grip rule. Or you can say right hand curl rule. It is better to say right hand curl rule. Now please see, in order to understand, please focus on my video. Please see, you can use this thumb as a direction of current, and this curl is representing the direction of magnetic field produced by the current flowing into the wire. So if current I is flowing into the wire, it is going to create a magnetic field, and that magnetic field is appearing in this manner. So how we will observe? We will observe from the board side. We observe it like magnetic line of forces are coming out. Magnetic line of forces are coming out from here. Okay, so I am representing it with a dot. With a dot. Now please see, dot means it is coming out. Okay, and going in is represented by this cross. Okay, now please see. Now please see. If this right hand thumb, then curl is representing the direction of magnetic field. Okay, so you can say, sir, by this you can say, sir, magnetic line of forces are appearing from our side like this to be the north and this to be the south of a magnet. Okay, let me show you once again. Let us suppose we have another wire. Say I am representing it by the blue one. We have another wire. Say ये है, ठीक है, और इस वायर में करंट सपोज करो ना, इस वायर में करंट बह रही है, मान लेते हैं, let us suppose the current is flowing into this wire in this manner. Okay, at the last I will introduce myself again. Okay, so please be with me. You have to be focused on this. See, again use the right hand rule. So here I am writing, please observe, if thumb is the direction of the current, then curl will represent the direction of the field produced by the current flowing into the wire, and that is because of the MMF. Okay, so now see, if this is your current I, then you can say, sir, by the right hand curl rule, the magnetic line of forces are appearing to be going in here and out here. The outside is said to be the north portion and the inside is said to be the south portion. So you can say, sir, it suggests us if two wires keeping a current, if two wires having a current in the opposite direction, then what type of force is going to be appeared on these wires? You can say, sir, south and south always repel. So you can say, sir, repulsive force will be there. Okay. On another hand, let us suppose we have a two wires. Again, let us suppose we have a two wires. Okay. बड़ा ध्यान दीजिएगा, मजा आएगा आपको, ठीक है. Let us suppose we have a two wires, this one and this one, and they are placed very near to each other, and they are going to they are having a current in this direction. I am representing it by the yellow one. Okay, say in this way. Okay, so अब क्या कहोगे? अब ये बोलोगे, sir, you can say, sir, this is your north and this is your south by the right hand grip rule. If the current flows in the direction of the thumb, then curl will represent the direction of the, curl will represent the direction of the field. Okay, now please see, this we have a north and this we have a south. Again, please observe, this is also going to create in the same fashion. Okay, so this will be north and this will be south. So you can say, sir, if the two wires which are being close to each other and they are having a current in the same direction, then they are going to face a attractive force. And that question is also asked in GATE. What happened when the transformer secondary is shorted on the secondary side winding of the transformer? So they are going to feel a attractive force. Okay? Now please see. From this I can write thumb and right hand curl. Okay, so you have to follow me, you have to subscribe this channel also. Okay, soon whatever you want, everything is going to be there. Okay, तो जो भी आप लोग यहाँ लिख रहे हो ना, वो बहुत जल्दी आपको जो है मिलेगा, टेंशन मत लो, ठीक है। जरा ध्यान से देखो बेटा, इसका बिल्कुल ही अलग अनुभव है ना, बहुत ध्यान से सुनते जाइएगा। Now please see, if thumb is the direction of current, as we have studied, if thumb is the direction of current, then right hand curl will represent the direction of magnetic field. Okay, right hand curl will represent the direction of magnetic field. Now please observe here also. Let us suppose we have a iron piece. Okay, let us suppose we have a iron piece, and on that iron piece I am going to wound a wire. Let be in this way. This is very important, please be with me. It will be very easy for you once you will be compatible. Okay, see, I have a iron, and a wire is wounded over a iron, but there is some insulation. Okay, because iron is also conductive, so there is some insulation in between the wire and this iron green one. This green is representing the iron and this red one is representing the wire, that is of maybe copper. Okay, now let us suppose I am going to supply one DC current in this fashion. So current is going to flow, say, in this way. Okay, so if the current going to flow in this way, let me magnify this. Let us suppose the current will going to flow in this way. Okay, so by the right hand curl rule, you can easily understood, whenever there will be a current flowing through a wire, there will be a magnetic field. Let us take this wire as a 3 different wire as we are observing. However, it is the same wire, and the wire from our observation section, it is carrying a current in this way. Okay, in the direction of the arrow. So आप बोलोगे, sir, as per the right hand curl rule, if the current flows in the direction of the thumb, then curl will represent the direction of the field. So you can say, sir, this will be your dot and this will be your cross. This is going to be the north and this is going to be the south. Can I say in this way? Similar to the next one also. Similar to the next one also. This is going to be the north and this is going to be the south. Similar to the next one also. This is going to be the north and this is going to be the south. As per the right hand curl rule, the dot and cross are representing, dot means the magnetic line of forces are coming outside of the board. It is feeling like it is coming outside of the board, and cross means it is going into the board. Okay, now please see. If you observe it, you can find that there are small, it is appearing like a small magnets. So when we keep the small magnets together, then what happened? It will becoming a big magnet. So this entire will act as a north and this entire will act as a south, and magnetic line of forces will take a path in this fashion. Okay, आज का सेशन जो था वो मैं आपको पूरा करूंगा, तो आप बहुत ध्यान से मेरे साथ बने रहिएगा, और आगे का जो भी सेशन है उसको मैं आपसे शेयर भी करता रहूंगा, और साथ ही साथ जो है आपके लिए मैं चीज़ों को और ज़्यादा इम्प्रेसिव लाने की कोशिश करता रहूंगा. ठीक है, सो प्लीज ऑब्जर्व हियर, this entire will acting as a north and this entire will acting as a south. So once again we can say that if the current flows in the direction of the curl, right hand curl, focus on my video, right hand curl, then thumb will represent the direction of flux. If you observe here, then currents are in this fashion. So if currents are in the direction of the curl in a coil, then flux, magnetic line of forces, will representing the direction of thumb. Is it okay? Yes, sir. Is it okay? Yes, sir. Now please see. Now please see. Now please see. ज़्यादा छोटा हो गया ये तो, कोई बात नहीं. Now see. Now see, again I am going to take ये लो, फिर से ना मैं दोबारा ले लेता हूं, इसी चीज को मैं दोबारा ले लेता हूं। दोबारा लेने का मतलब क्या हुआ, मान लो कि तुम्हारे पास, थोड़ा बड़ा बनाता हूं यार, मैं बड़ा नहीं बना पा रहा हूं मैं। let us suppose we have a iron core here, and the windings are wounded over this iron core in this manner. कहां चला गया भाई? So the windings are wounded onto the core in this manner. Okay, मैं पहले फिगर बनाने की सोचा था, बट ज्यादा अच्छा क्या होता है कि विद अ फिगर अगर आप देखते हो ना बनते हुए, तो आपको ज्यादा समझ में आता है। नाउ प्लीज सी, say the current is flowing in this fashion. So this is the previous one and this one is same. Okay, so let me make it a bigger, so both are appearing to be the same. So till we have completed that if the current is flowing in this way, that is in the direction of the curl of right hand, then the magnetic field will be in the direction of the thumb. Okay, yes sir. So sir, you can write here that if thumb is, if right hand curl is the direction of current, then thumb will represent the direction of magnetic field. Thumb will represent the direction of magnetic field. Okay, now see, again I am going to show the same thing, but the way of winding is going to be changed, and that is the very important part of the entire transformer. Most of the students are not capable to understand the dot polarity, and therefore they are not able to understand the entire transformer. Now please see, I am trying to show you again. We have a same core. Again please see, we have a same core, and we have a same core. तो चिंता मत करिए, soon I am going to be on board also, so don't worry about that. We have a same core, but the way of winding is different. Say the way of winding is in this fashion. Okay, समझ पा रहे हैं? Only I am going to change the way of winding. In the previous, the way of winding is clockwise, and now I am going to make it in an anti-clockwise direction. Okay, so see. सर आप डाउट नहीं आंसर करेंगे इसलिए डिसलाइक और बढ़ जा रहा है. I always love to all my student, and I believe whatever I am, whoever I am, that is only because of my students. Okay, so I love all my students, and definitely I never leave my students under any circumstances. Now please see, we have a current I here, and the current I here will be in this way. The same source, same current, same wire, each and everything will remain same. Only the thing different is the way of winding, and this the way of winding is very important. What is important in that? Please see. What is important in that? Please see. आएगा भाई, सुन रहे हो? सभी लोग बने हुए हो? गुड इवनिंग बेटा पूनम. Now see, अब मुझे लगता है एवरीवन इज डेडिकेटेड, सो आप लोग ना मेरे से चैट पे लिख सकते हो, है ना? एक चैट से दूसरे चैट तक लिखने में थोड़ा सा टाइम रखना, तो मैं सबका आंसर आउट भी करता जाऊंगा. नाउ प्लीज सी, If the current will flow in this fashion, then what happened? Again, you can go with the right hand curl rule. If thumb is the direction of the current, then curl is the direction of the magnetic field. And if you observe here where my cursor is, please observe on the board. If you observe here, then you found that the current is in this way. So it is going to create a magnetic field in a manner that this is going to create the upper portion as a south and lower portion as a north. And the same fashion the next wire will have, south and north, south and north. So it looks like a small magnets. These currents are creating a field, and if we observe the cumulative effect of the entire field, then this entire will going to act as a south and this entire will going to act as a north. Is it okay? So what happened? Everything is same. Core is the same, current is the same, everything is same. Only the way of winding is different. If you observe, the flux at the same time is here in this way. Is it okay? So flux position is changed. Now it is downward. The magnetic line of forces is, if curl is the direction of the field, then thumb is the direction of the, if curl is the direction of the current, then thumb is the direction of the field. Focus on my video. If right hand curl is the direction of the field, then current, then thumb will represent the direction of the field. Is it okay? So आपने बोला सर अगर कर्ल हमारा करंट की डायरेक्शन है तो थंब की डायरेक्शन में क्या आ जाएगा? थंब की डायरेक्शन में आ जाएगा सर हमारा फील्ड, और यही तो सबसे इंपॉर्टेंट बात है, हम यही तो समझना चाहते थे। ठीक है, सो नाउ वी नो अबाउट द राइट हैंड कर्ल रूल, thumb and right hand curl. I am repeating it again so it will be very beneficial for you. By the right hand curl rule, we know that if current flows in the direction of the thumb, then right hand curl will represent the direction of the field. Is it okay? And if current flows in the coil in a curl, then thumb will represent the direction of magnetic field, and thumb always denotes the north side of the material. Is it okay? So that is only representing where the dipoles are going to be aligned and how it is going to be aligned. Is it okay? So now we know about the right hand curl rule and how the magnet will be there. मान लीजिए आपको एक मैग्नेट बनाना है. Let us suppose you have to make a magnet, say electromagnet. The entire machine will work on the electromagnet only. Okay, अब मेरा हाथ थोड़ा सा अच्छा से खुल रहा है इस पे, so देखिएगा. Let us suppose we have to create a magnet. Please let me know in the comment section if I want this side to be the north one and this side to be the south one. Then how I have to connect the supply. Now please see. This is your coil. Let us suppose this will be your coil. Okay, we have a iron and this will be your coil. Okay, I just wanted to know what polarity of voltage I have to apply here on terminal AB so that I will get the desired polarity of this electromagnet. This electromagnet will have a dipoles. Yes, this electromagnet will have a dipoles, but these dipoles are randomly oriented. Okay, क्या मतलब हुआ? सर हमारे पास आयरन मटेरियल है, उसमें डाइपोल्स हैं, लेकिन ये randomly oriented है. We want them to be aligned in one direction and then only it will act as a magnet. Is it okay? Now see, this magnet term is very important. The entire machine, it doesn't matter it is a transformer, rotating machine, anything, the entire machine will going to work onto the magnets only. Okay, so that term magnet is very important. Please see. What should be A and what should be B? Okay, now please see. By the right hand curl rule, we know that in order for this terminal to be the north and this terminal to be the south of this iron, by the right hand curl rule, current must flow in this way. I am representing it by the different color. Please see, in this way. Yes sir. So you can say sir in this way. So in order to get this must be positive and this must be negative. Now you know how to make a magnet. electromagnet. Is it okay? Is it okay? Now you know how to make electromagnet. सर एक रिक्वेस्ट थी कि आप पहले से बनी स्लाइड्स में पढ़ाइएगा अनअकैडमी प्लस पे, कोई डायग्राम जब तक टीचर बनाए समझ नहीं आता. ओहो, don't worry about that. Okay, whenever you are going to be a plus on plus, then I have a pre-planned schedule. Okay, so don't worry about that. This is just an introduction class. We are just going to know about each other. That's all. So what is this? Now you know how to make a magnet. Now this is going to be the north and this is going to be the south. What happened if I connect the supply in a different fashion? So in the same diagram, if I change the way of terminal, let us suppose I am going to make the supply in this manner, then what happened? Please let me know. The current will flow in this fashion. Yes, sir. The current will flow in this fashion. Please follow the red one. Let me make it fresh. ये ना YouTube पे ये थोड़ा सा वैसा चलता है, बट ऐप पे ना बहुत अच्छा चलता है. ठीक है, तो क्या कर सकते हैं, अब कोई बात नहीं. हो सकता है मैं नहीं चला पा रहा हूं. सो नो इशू. I only believe in learning. So learning can make perfection in anything. Now please see, this is your current. So if the current will flow in this way, then what happened? सर हम बनाना तो इसे नॉर्थ चाहते थे और इसे साउथ. वी वांटेड टू मेक दिस टर्मिनल नॉर्थ एंड दिस टर्मिनल साउथ, बट इफ वी आर अप्लाइंग अ supply in this fashion that current flows in a red arrow direction, then by the right hand curl rule, if the current flows in the direction of the curl, then thumb will represent the direction of the field, and therefore this is going to be the north and this is going to be the south. So now you know how to make a magnet. Is it okay? Very good. Now you know how to make a magnet. Is it okay? Very good. So now we know about the right hand curl rule and also we know how to make a magnet. Is it okay? चलिए अब हम आ जाते हैं ट्रांसफॉर्मर के बारे में जानने के लिए. तो ट्रांसफॉर्मर किस चीज पे काम करता है, हाउ इट इज गोइंग टू सप्लाई विदाउट हैविंग एनी इलेक्ट्रिकल कनेक्शन. ओके, सो इन ऑर्डर टू अंडरस्टैंड दैट, फर्स्ट ऑफ ऑल वी नो अबाउट द फैराडेज लॉ ऑफ इलेक्ट्रोमैग्नेटिक इंडक्शन. सो व्हाट इज फैराडेज लॉ ऑफ इलेक्ट्रोमैग्नेटिक इंडक्शन? इट स्टेट्स दैट, बहुत ध्यान से देखिएगा और कमेंट सेक्शन में लिखिएगा. गुड इवनिंग पराक्षित. विपिन यादव, गुड इवनिंग बेटा. या फुल कोर्स आपको ऐप पे मिलेगा. यूट्यूब पे इंग्लिश में चलता रहेगा कोर्स, तो यूट्यूब पे भी आपको फ्री में भी क्रैश कोर्स मिलेगा. दिस इज अ क्रैश कोर्स. हाउएवर आई एम नॉट टेकिंग द फर्स्ट क्लास लाइक अ क्रैश कोर्स, सो डोंट वरी अबाउट दैट. इट इज अ क्रैश कोर्स एंड इट गोज वेरी रैपिड, सो डोंट वरी अबाउट दैट. तो बहुत बढ़िया सर. अनअकैडमी प्लस पर कंप्लीट कोर्स कब लॉन्च करेंगे? वेरी सून. नाउ सी, Faraday's law of electromagnetic induction. It states that a EMF is induced in a coil when a magnetic flux linking the coil changes with time. We have a best way to analyze that. Okay, so don't worry about that. Soon I am going to show you. What is Faraday's law? Faraday's law states that an EMF is induced in a coil when a magnetic flux linking the coil changes with respect to time. It doesn't matter whether the flux is changing or the field is changing. It doesn't matter. Similarly here, if you observe, if the flux linking a coil varies as a function of time, then voltage is induced across the terminal. You can say, sir, either you can write this statement or you can say in this way. Again, I am repeating. An EMF is induced across the coil when a magnetic flux linking the coil changes with time. If the flux linking a coil varies as a function of time, then a voltage is induced across the terminal of that coil, and it is represented by, please see beta, and it is represented by E is equals to plus minus n d phi by dt. I wanted to say one thing that is personal apart from this. So always remember, whatever anyone shows to you, may that is not as true as you feel. Okay. So मैं भी ना बहुत अच्छा actor हूँ. So if I act, maybe you are not capable to understand कि whether who is the right one. Okay. So don't write anything in the comment section. It may causes to bar you on this channel. So please be focused on the topic only. Now see, I'm repeating it again. It states that an EMF is induced in a coil when a magnetic flux linking the coil changes with time. So E is equals to plus minus n d phi by dt. This plus and minus is very important, and that is because of the Lenz's law. Now, what is this Lenz's law says? Lenz's law says the polarity of induced EMF, the polarity of induced EMF is such that if it allowed to cause a current, then current so produced must oppose the cause. तो दो बातें हो गई. क्या? जब भी कभी मैग्नेटिक लाइन ऑफ फोर्सेस से कोई कॉइल इंटरैक्शन में आती है और मैग्नेटिक लाइन ऑफ फोर्सेस समय के साथ या कॉइल चेंज करती है पोजीशन, सो वहां पे एक ईएमएफ इंड्यूस होगा. And that induced EMF is basically d psi by dt, but I am just representing the final equation, that is plus minus n d phi by dt. Okay, so this n is the number of turns of that coil and d phi by dt is the rate of change of flux. Okay, this plus and minus sign is because of the Lenz's law, and Lenz's law is very simple. It only states the Newton's third law in electrical domain. Like every and each action, there is equal and opposite reaction. So this term is very important because it applied throughout the life. हर एक चीज पे लगता है. ठीक है? So the polarity of induced EMF is such that if it allowed to cause a current, then current so produced must oppose the cause. Let me try to make you feel better. Okay. Now please, we go through the question in order to understand the entire concept up till now. Okay. So we are going to understand the Faraday's law of electromagnetic induction, the term n d phi by dt, and I am also considering to know about the polarity. Okay. So what the polarity? Polarity means what should be the polarity? Polarity of induced EMF is such that if it allowed to cause a current, then current so produced must oppose the cause. बहुत तगड़ा. चलो इसको ना एक क्वेश्चन के जरिए समझते हैं. तो चलो यहाँ पे जरा देखो, क्वेश्चन तुम्हें दिखाई दे रहा होगा, मैं थोड़ा बड़ा कर देता हूं, है ना? नहीं होगा, ठीक है, कोई बात नहीं. ये देखो क्वेश्चन आपको दिख रहा है. ओके, सो क्वेश्चन दिख रहा है. नाउ सी, a coil of 2000 turns surrounds a flux of 10 milliweber. देखो जरा ध्यान से सुनना. सर योर कंसेप्ट इज कॉम्प्रिहेंसिव एंड इजी टू अंडरस्टैंड. थैंक यू निहार, थैंक यू बेटा. सर अच्छा, so soon I am going to tell each and everything at the end of the class, so you have to be with me. Okay, now see, we have a coil of 2000 turns. Please see, I am going to draw that figure. Suppose we have a iron here, iron material, okay, and a wire is wounded over this iron. A wire is wounded over this iron, say in this way. The relative sense is very important. The way of winding is very important. Whether I am going to do it in a clockwise or anti-clockwise, because in that way the magnet is going to be, the polarity of magnet is going to be available. Okay, so say we have a magnet here. Don't judge me by this representation, okay? My representation is very good. So those who are new, they have to subscribe this channel because this representation is very soon going to be very good. See, I only believe to be happy. This is the only way to give to live a healthier life. Okay, so sir, it's understandable to me. Thank you. Now please see. Let us suppose we have a permanent magnet and that permanent magnet is holded in some non-magnetic material. Say this to be the handle is acting as a non-magnetic material here and a permanent magnet north and south. Is it okay? And we have this. Okay. So this is the same magnet but the positioning is different. Now please see, we have a coil of 2000 turns. This coil is of 2000 turns. Okay, and this coil is of 2000 turns, and when this coil is at, say, when the magnet is at, say, position 1, it is very interesting. So please be with me. अभी तक जो भी पढ़ा है ना, all I am going to conclude within a minute. This is your position 2. So see, a coil of 2000 turns surrounds a flux of 10 milliweber produced by a permanent magnet. Okay, by a permanent magnet shown in figure. The magnet is suddenly withdrawn, causing flux inside the coil uniformly drop to 5 milliweber in 1/10 of a second. What is the voltage induced across the terminal AB? So whenever there will be a change in flux linking the coil, there will be an induced EMF across the coil. I am saying this to be the coil terminal A and coil terminal B. Not only I am interested to know about the induced EMF magnitude, I am also interested to know about the polarity of induced EMF in order to understand the Lenz's law. Okay. So please share this session to everyone. Okay, this is very important. See, we have the magnetic line of forces to be taking path through this iron core as I have represented here with the blue lines. Okay, and this magnetic field, say, uniformly distributed, and this will be equals to 10 milliweber when it is at position 1. Okay, so 10 milliweber when it is at position 1. In 1/10 of a second, it is shifted over to position 2. Okay, अरे फैराडे भी ऐसे ही जाने थे, ठीक है, तो तुम सुनते जाओ. Now see, we have this to be the okay. Now see, position 1 and position 2. This coil surrounds a flux of 10 milliweber when the permanent magnet is at position 1. I am shifting this magnet from position 1 to position 2 by applying a mechanical force on this. Okay, so let us suppose it is in my hand and I am just shifting it from position 1 to position 2. So if I am shifting it in position 2 in 1/10 of a second, then the flux, it is not going to be uniformly dropped down, but let us consider, in order to understand this, let us consider that it is dropped down from 10 milliweber to 5 milliweber. Why it is dropping down? Sir, it is very easy to understand. अब ऐसा थोड़ी है कि we have a magnet in our hand, so it is going to be appear attractive force even though the iron is far away. तो आप बोलोगे सर ऐसा थोड़ी हो सकता है. Okay, now see, the flux is uniformly dropped down. This uniformly dropped down is just my consideration in order to understand. See, to 5 milliwebers. So the total change of flux is 5 milliwebers and the total change of flux in the core is occurring in 1/10 of a second. So whenever there will be a flux linking the coil changes with respect to time, there will be a induced EMF as per the Faraday's law of electromagnetic induction. As per the Faraday's law of electromagnetic induction. And this induced EMF is plus minus n d phi by dt. So you can say, sir, the induced EMF, because the windings are bounded over that iron, if the iron is going to carry, if the iron is facing a change in flux of 5 milliwebers, then same is linking with the winding also, and winding suffers the same. So this will be equals to plus minus n d phi by dt. Those who are observing me by today, in order to get the entire syllabus, you have to subscribe this channel, okay? So don't forget to subscribe. Now please see, E is equals to plus minus n d phi by dt. So I can say plus minus, what is n? N is 2000, okay sir, and d phi by dt. So what is d phi by dt? D phi by dt is the rate of change of flux. So what is rate of change of flux here? Rate of change of flux is 10 minus 5 in 1/10 of a second. So you can say, sir, 5 milliweber is the change, and the change occurs in 1/10 of a second. So milliweber, I can write it as 10 to the power of minus 3 in Weber upon 1 by 10. So you can calculate the value. So what is the value? ऐसा है, no one goes anywhere. See, if you observe here, then what is the value? Value is sir, it's up to Varun sir. Sometimes only we don't decide. हाँ जी, 100 volts. Yes, very good. So the voltage will be 100 volts. अब आप बोलोगे सर, यहाँ पे 100 volts तो आ रहा है, but whether it is a plus 100 volts or it is a minus 100 volts, how we decide it? Okay, so please see here. The entire machine is based on this concept only. Soon I am going to show you all the machines. Okay, so please observe. Though my writing is not so good, but this feature is new for me, so don't judge it by the writing. Okay, see, let us suppose we have a load here. Okay, now I am interested to know whether plus 100 volt or a minus 100 volt, and this term is very important, whether it is plus 100 volt or a minus 100 volt. Now please see, again I am again repeating the things. Now we know about the right hand curl rule. Yes sir. We know about the right hand curl rule. Yes sir. What is right hand curl rule? Right hand curl rule says, if the current flows in the direction of thumb, then right hand curl is the direction of magnetic field. Or if the current flows in the right hand curl of a coil, then magnetic field is the direction of thumb. Magnetic field is in the direction of thumb. Okay. Faraday's law says EMF induced in a coil whenever magnetic flux linking the coil changes with respect to time. What Lenz's law says? The polarity of this induced EMF is such that if it allowed to cause a current, then current so produced must oppose the cause. So why there will be an induced EMF here? The induced EMF is here because of a shifting of this magnet from position 1 to position 2. Okay sir. So why this 100 volts will be here? Because of shifting of this magnet from position 1 to position 2. Okay, so as per the Lenz law, as per the Lenz law, the shifting will be not, the shifting will be opposes by the current flowing here. Yes, sir, मतलब ये है कि the polarity of the voltage across AB must be in such a way that if it allowed to cause a current, then that current will create this to be a magnet, and that magnet doesn't allow this position shifting of permanent magnet from 1 to 2. So in order to oppose the position shifting when the current flows, it must create a magnet, and that magnet must be here as a south and here as a north. And in order to have a south here, what is the direction of current? You can say, sir, direction of current must be this. So the polarity of induced DMF is such that, polarity of induced DMF is such that if it allowed to cause a current, let me make it red, slightly bigger. Sir, current must flow in this fashion. क्या हुआ? Again I am repeating, please see. The induced EMF polarity is such that if it allowed to cause a current, then current so produced must oppose the cause, and in order to oppose the cause, this terminal must be south and this terminal must be north. In order to have this to be the south and this to be the north, current must flow in this fashion. Now, whether A is positive or B is positive, and that is depends upon the consideration, and that is why there will be a plus and minus. If someone is considering that B is acting as a source here and it is going to give a supply in this fashion as a positive terminal, then it will be different. But always load will decide the polarity. Please see, please see. मेरे पास कोई सादा पेज बचा है? Please see. मैं ना अपनी बात को यहां पर रखने की कोशिश करता हूं, बहुत ध्यान से देखिएगा, ठीक है, बहुत ध्यान से देखिएगा. प्लीज सी, let us suppose we have a component here. Okay, this is an electrical circuit and we have a two components here. Okay, say a DC one. Okay, so I am just representing the direction of current in this fashion for this voltage source. So which one is a source and which one is a load? We have a two component, say 1 and 2. You have to write in the comment section which one is source and which one is load. Again I have the same thing, this to be plus and minus, and we have a load here. ठीक है ना बेटा? तुम्हें मुझे बताना है कि if we have two components 1 and 2, then which one is source and which one is load? Please tell me. अरे बेटा डोंट वरी अबाउट दैट, 2 मिनट रुक जाओ, यू विल गोइंग टू लव मी. ओके, जो लोग भी लिख रहे हो ना वर्स्ट वाला, तो थोड़ा सा रुक जाओ, यू आर गोइंग टू फॉल इन लव विद मी बिकॉज आई लव दिस मशीन सब्जेक्ट. ओके, सो प्लीज सी which one is source and which one is load. You can say, sir, as per the direction of current, you can say this to be the source and this to be the load. Okay, similarly here also this to be the load and this to be the source. Okay, yes sir. So by observing the direction of current, you can tell me, you can easily state out of the two components which one is source and which one is load. So please observe, always load decide the source. Okay, so direction of current is always observed by the load. Now see here, आपने बोला सर current is going in this fashion. So for this load, for this electrical load, this terminal must be a positive one and this terminal must be a negative one. if I am writing this to be the positive and this to be the negative. Why? Because if this is a voltage source, then for the load this induced EMF is a source, and for the load induced EMF is a source, and instantaneously it founds that this to be positive and this to be negative. So you can say, sir, with A as positive and B as negative, with A as positive and B as negative. Okay, now please see, अगर हम A को पॉजिटिव और B को नेगेटिव कहते हैं तो क्या ये बात सही है? आइए वेरीफाई करते हैं. Whenever we increase the load, then load increase means current increases. Why? Because for the same voltage source, if we are going to increase the electrical load, it means we are going to connect the load in parallel. So when the number of parallel impedances are increasing, it means overall impedance is decreasing, and therefore current is increasing. So in electrical system, whenever load increases means current increases. With the rise of this current, please see. With the rise of this current, please see. With the rise of this current, what happened? The MMF increases and this portion will become more strong south. When it becomes more strong south, then shifting of this magnet will become a very difficult task. Why, sir? Now more energy is required in order to shift this magnet from this position 1 to position 2. This more energy required. Why? Because you are consuming, because load is demanding more. So as soon as the load increases, MMF, this S increases. So this MMF increases means this will become a strong magnet and it will be difficult to shift from position 1 to position 2 because more energy is required. Ultimately, the energy consumed by the load is supplied by this shifting only. Is it okay? So yes, sir, we are very comfortable now. We are very comfortably understand that current must be in this fashion because as per the Lenz's law, the polarity of induced EMF is such that if it allowed to cause a current, then current so produced create a magnetic field in such a way that opposes the cause. So that is now opposing the shifting. Is it okay? Now please see, with the A positive and B negative, we say induced EMF is equals to plus 100 volts. Why I am saying this? Because in an actual practice, always load decides the polarity of induced EMF, as induced EMF is acting as a source for the load. However, in some practice or in books, they haven't represent this one in some of the books. Okay. Or one can say, sir, if I am considering in this fashion, say this to be A and this to be B. Okay. And now I wanted to know about the polarity of induced EMF. So if someone marked this to be the positive as considering the current flowing into the coil and this to be negative considering that current is flowing into the coil by this voltage source, then the induced EMF will become opposite to the previous polarity. Yes, sir. Previous polarity is this one. And now it is opposite to the previous polarity. So in case if the opposite to the previous polarity, we mark it as with A as a negative and B as a positive. We mark it as E is equals to, हाँ beta, minus 100 volts. So it means I am considering it to be the minus ND phi by dt. इसका मतलब क्या हुआ सर? It can be a plus or it can be a minus. It totally depends which terminal you are considering to be the positive. Which terminal you are considering to be the positive. क्या मेरी बात समझ पाए? Okay. Okay. अगर कोई मेरा स्टूडेंट होगा ना सच में, तो वो मुझे जानता है कि मैं कैसा हूं. ठीक है. सो अगर कोई कभी मेरा स्टूडेंट कभी रहा होगा ऑफलाइन ऑनलाइन, सो दे ऑल नो व्हाट आई एम एंड हु आई एम, सो एंड व्हाट इज द नेचर आई हैव. सो डोंट राइट एनीथिंग in the comment section as it irritates me. You can't write unnecessary things, okay? ठीक है. आपने कहा सर ये वाली जो बात आपने बताई है इसको हम लोग थोड़ा थोड़ा समझ पाए, अभी थोड़ा आप कंक्लूड कर दीजिए. तो कंक्लूजन ये है कि इंड्यूस्ड ईएमएफ की पोलैरिटी जो है वो आप कौन से टर्मिनल को देख के मार्क करते हो उसके बेसिस पे हम कहते हैं वेदर वी हैव टू टेक इट एज प्लस ND5 by dt और वी हैव टू टेक इट एज माइनस ND5 by dt. सर कैन यू प्लीज एक्सप्लेन मी वंस अगेन? यस. नाउ प्लीज सी, टाइमिंग हो रहा है, ठीक है. सेशन खत्म करने से पहले मैं इस बात को फिर से आपको एक बार बताना चाहता हूं. प्लीज सी. Let us suppose we have नहीं बन पाएगा. Let us suppose, sir, teach in a blackboard as you did previously. Yes beta, very soon. ये भी बहुत अच्छा मोड है ना बेटा, बस ये मेरे से थोड़ा सा टाइम लगता है इसको समझने में ना, 1-2 दिन में बहुत अच्छा सा आ जाता है. तो डोंट वरी अबाउट दैट, आई एम कीपिंग माई प्रैक्टिस ऑन. दिस इज जस्ट एन इंट्रोडक्शन सो दैट एवरीवन नोज कि whether they are able to understand me or not. Now please see, let us suppose I have a question. Let us suppose we have this to be the now I have a question. You have to tell me if you are able to understand. It means I made you feel about this Lenz's law and Faraday's law of electromagnetic induction. कल आप आओगे ना तो कल बिल्कुल डिफरेंट पाओगे. Now please see, let us suppose I have a magnet. ज्यादा मजा इस पे ही आएगा बेटा, ज्यादा मजा इस पे ही आएगा. जिसका ऐप है ना वो बहुत मजेदार है. Now please see, let us suppose we have a north and south. Okay, I just wanted to know whether you are able to understand the things or not. Okay, so please answer me. This to be the north and this to be the south here, and let us suppose I am shifting it in say 1/10 of a second again from position 1 to position 2. Okay, say the magnetic line of forces are here in this fashion. You have to tell me about the polarity only. The values are going to be the same. Means again I am making it to be 2000 turns. Each and everything is same. Okay, we have A and B, and I am shifting it from position 1 to position 2. So only you need to tell me which terminal is positive and which terminal is negative in the comment section. सी बहुत सारे लोग क्वेश्चन पूछ रहे हो, मैं अंत में जवाब दूंगा, डोंट वरी अबाउट दैट। बहुत सारे लोग क्वेश्चन पूछ रहे हो ना, मैं जवाब दूंगा, डोंट वरी। Please let me know which one is positive and which one is negative if I am shifting this magnet from position 1 to position 2, and the values is fixed, that is equals to 100 plus minus 100 volts. So everything is same. Only I am saying if this is the case, magnet is pushing towards this iron piece, then which one is positive and which one is negative? Haji, which one is positive and which one is negative? Please write in the comment section if you are able to understand. Let me again introduce the same thing, because this is the most important part of the entire machine. What is right hand curl rule? If the current is in the direction of the thumb, then curl is the direction of the field. Okay, and if curl is the direction of the current, then thumb is the direction of the field. Faraday's law of electromagnetic induction says, it states an EMF is induced in a coil when a magnetic flux linking the coil changes with time. Lenz's law says the polarity of induced EMF is such that if it allowed to cause a current, then current so produced must oppose the cause. Now come to this. And tell me which one is positive and which one is negative. Okay? Jaldi. Comment section is very important. ज्यादा लंबा सेशन नहीं लूंगा, बस सेशन को अब थोड़ी देर में रखूंगा अपनी बात को कहते हुए, ठीक है? विच वन इज पॉजिटिव एंड विच वन इज नेगेटिव? सर इफ प्लीज ऑब्जर्व सर, इफ मैग्नेट इज शिफ्टिंग फ्रॉम पोजीशन 1 to position 2 in some duration, and then there must be a change in flux because of the position of change in the position of the magnet, and the induced EMF must be such that, as per the Lenz's law, the polarity of induced EMF must be such that if it allowed to cause a current in the wire, then current must be in such a way that it will opposes the cause. And in order to oppose the cause, this must going to be the south or north? Sir, this must going to be the north, because north and north always repel each other. Is it okay? And this must going to be the south. By the right hand curl rule, in order to have this to be the north polarity, what should be the direction of current? Sir, the direction of current must be this. If the direction of current is a right hand curl, then thumb is the direction of field. Is it okay? Yes, sir. And if the current is flowing in this fashion, then always the polarity of induced EMF is decided by the load. Is it okay? Because for load, this induced EMF is a source. So you can mark this to be the positive and this to be the negative. If you are marking in this way that A is positive and B is negative, then you can say induced EMF is plus 100 volts, because you are marking as per the Lenz's law. However, if someone marked in a different way, without considering this load, if someone marked in the way that current is flowing in this way, so this must be positive and this must, if someone marked in this way, then you can say, sir, if A is marked as a negative and B is marked as a positive, then we consider it in this way. सर ये हमेशा आप जो कह रहे हो ये बात को सेटिस्फाई कर रहा है? Yes. Because whatever energy is consumed by the load, is provided by this mechanical side. Is it okay? So if you are going to increase the load, current increases. With a rise in current, potential increases. Magnetic potential increases means it is going to be more, it is going to take more effort in order to shift from position 1 to position 2. Sir, why the polarity is going to be the same? Because I have changed the way of winding. If I left the previous way of winding, then the polarities are changed. So I am hoping you are getting each and everything. इज इट ओके? मोहित गोयल सर थोड़ा फास्ट हो गया, मे बी, बट आई एम होपिंग कि नाउ यू आर कंफर्टेबली नो अबाउट द राइट हैंड कर्ल रूल एंड अबाउट द पोलैरिटी ऑफ इंड्यूस्ड ईएमएफ. ओके, तो ये दो बातें तो आपको मेरी समझ में आई होंगी. अब चूंकि आज का जो है मैं बहुत ज्यादा लिख नहीं पाया इस पे, बट ठीक है. तो आई एम होपिंग कि आपको ये दो बातें समझ में आई होंगी. बहुत सारे लोग क्वेश्चन पूछ रहे थे, हाँ, तो बहुत सारे लोग जो क्वेश्चन पूछ रहे थे उसका जवाब दिया जाए. सो एक बार जल्दी से आ जाओ, ठीक है. मे बी समवन wanted me to react, but see, always love your work. Always love your work, because anyone can stop loving you at any time. So always love your work. As a student, your work is to focus on the studies, so you have to focus on the studies. This is the only thing that I have to say. Okay. Very good. So I wanted to tell you the things again. Please observe here. This is a Telegram channel that you can follow. Okay. So in this Telegram channel, whatever I teach, I will provide in a PDF format. Okay. These are the different channels for the different sessions. Like if you observe here, that is GATE, EECIN, Kreatryx. You can please observe here also for the question series, for the electrical junction. So these are the different channels for the where you can get the things. Okay, so you have to subscribe all of them. Not mechanical one, you are from electrical, so for the electrical one you have to subscribe. If you want to get connected with me, then you can just download the app and use my code. Okay, so to log in on the app, you can use my code and then you will get my link directly. किसी को कुछ पूछना है? सर मेरा काम है पढ़ना और कहीं भी पढ़ना. थैंक यू बेटा. ठीक है, ठीक है, मजा आया होगा. मजा आया होगा, ठीक है. So soon I'm going to improve this writing portion more. The this platform is very good for you in many respects. I have planned many things, so soon I am going to execute each and everything. Okay. ठीक है. So that is all for today. I am going to continue this crash course for the entire month. So those who wants to get the entire crash course in English, they can follow me on this channel. Okay, and for Hindi you have to subscribe on Plus by using my this code. Okay, and there you will get a special classes, and that is also free. You will get a special free classes there also. Okay, so I am hoping कि आप सभी लोगों को अच्छा लगा होगा. थोड़ा बहुत चीजों को बढ़िया कर दूंगा. आपको चैनल सब्सक्राइब करना है, लाइक करना है, ठीक है. एक बार जल्दी से थंब बना दीजिए so that unwanted comments will be go out and we will start with a very positive energy. Okay, I try to make the sessions to be very good for you. Thank you, good night.